Hi, welcome to my video on finding dy dx, which is the derivative in terms of x. And this is video number 1, where I'll show you many examples. Find dy dx of each. Number 1, y equals 2x cubed plus 6x squared minus 7x plus 4. Notice y is a function of x. Y is on the left and x is on the right, so we can do dy dx right away. So the derivative of y is dy dx, and derivative of all these x's, use the power rule. So this is a constant, so that's a 2, and times 3, and 3 decreases by 1 to become a 2, and 6 times 2, 2 decreased by 1 become a 1, and a negative 7x, the derivative is negative 7, because x decreases by, that's a 1 there, it's decreased by 1 to become 0, x to 0 is 1, derivative of a constant is 0, so we have dy dx is equal to 6x squared plus 12x minus 7. So that's the first one. I used explicit differentiation to work that out. But the rest of them, I will have to use the implicit differentiation because I can't solve it for y. It's easier to use the implicit differentiation. I could even use implicit here because it's just all the x's are on the right and it's the same. But here, now, it's going to be x squared plus y squared equals 9. So d dx on x squared is 2x, and d dx on y squared, so the derivative, same, that was an x, so that's a 2y, but because I'm doing d dx on the y, I get a dy dx, and the derivative of a constant is 0, so 2y dy dx is equal to negative 2, because I'm solving it for dy dx, so the negative 2x moves over to become 2x moves over to become negative. Now I divide by 2x, divide by 2y to isolate the dy dx, so I have negative 2x divided by 2y, and that becomes, the 2's cancel, so I get a negative x over y. And another one, 4x minus y cubed equals 0. Again, d dx on 4x is 4. And the power rule, derivative of the y is 3y squared. And because I'm doing the derivative in terms of x, then I get a dy dx. Every time I do the derivative of y in terms of x, I'll always get a dy dx. Derivative of 0, constant is 0. So that gives me negative 3y squared dy dx is equal to negative 4. I'm solving for dy dx, so the 4 moves over to become negative. Now I have dy dx is equal to negative 4 divided by negative 3y squared. Two negatives become a positive, so it's 4 over 3y squared. And we have another one. Notice we have 2xy minus x plus 1. This is a product, so the derivative of, this is f and g, so the derivative of f is 2 times y plus f times the derivative of g, which is the y. Derivative of g is y prime. Oh, I say y prime. Let's do dy dx. I could use y prime, but I'm using dy dx instead right now. And the derivative of x is negative 1, and the derivative of constant is 0. The derivative of 0 is 0, so I get 2y plus 2x dy dx, and that's a minus 1 equals 0, so 2x dy dx is equal to negative 2y plus 1, and I have to solve for dydx, so I'll divide by 2x on each side. So negative 2y plus 1 over 2x. 4 problems done. Again, the more problems you see done, hopefully the better you'll understand. Now, find dy dx of each. Number 5. So notice we have x squared minus 4x plus y e to the 6th power equals 0. So if this is to the 6th power equals 0, that means that x squared minus 4x plus y must be 0, because 0 raised to the 6th power is 0. Now we do the derivative, ddx. So the derivative of x squared is 2x. Derivative of 4x is 4. The derivative of y in terms of x is 1 dy dx. Derivative of y is 1. And it's dy dx. Derivative of 0 is 0. And I have to solve it for dy dx. So dy dx is equal to negative 2x plus 4. I just did this one to show you that the inside of this is a 0, and then I do the derivative. Number 6, x minus 1 over y squared plus 3x equals 7. And notice we have a quotient here, and that's f over g derivative. So the way I work, I do the derivative of f times g minus f derivative g over g squared. And again, when I look at books, I see them flip this around, but I like to do it with the derivative of f first, and then derivative of f, because f is on the top. I do derivative of f g, subtract f, derivative g. So this is a quotient here, so this is the f. So the derivative of x minus 1 is 1 times g, which is y squared, subtract x minus 1, which is the f, and times the derivative of y squared, which is 2y, and always we get derivative of y in terms of x, we get a dy dx, plus derivative of 3x is 3, and the derivative of 7 is 0. So what we have now, we have to simplify this. We got a y squared minus 2y x minus 1 dy dx plus 3 equals 0. So what we have is, now we got to isolate the dy. Oh, I forgot. And again, I forgot to put that over. That's y squared. I forgot to do f. I did the f prime g and f g prime over g squared, but I didn't put it over the g, which is y squared, being squared. So that's y to the 4th. Now, I can move this 3 over and isolate this fraction, or I can multiply the whole fraction by common denominator is y to the 4th. So if I multiply this by y to the 4th, multiply 3 by y to the 4th, multiply 0 by y to the 4th, I'll have no fractions. So they cancel out, so I get y squared minus 2y x minus 1 dy dx. 3 times y to the 4th is 3y to the 4th, and 0 times y to the 4th is 0. Now, I'm solving it for dy dx, so I'll leave this expression by itself. So I'll go negative 2y x minus 1 dy dx equals negative 3x to the 4th minus y squared. I'm putting it in descending order in terms of y's. So I have it isolated, so now I divide by each side by negative 2y x minus 1. So dy dx is and what happens is that make this simpler, so I can take the negative at the top, and I can also take a y squared. as a binomial here. So that gives us 3y squared plus 1 all over negative 2y x minus 1. So dy dx becomes, the negatives cancel, become positive. So y squared divided by y is y. 3y squared plus 1. And the negatives became positive, and the y cancels, so I get a 2 times x minus 1. Again, a little different problem. I wanted to use the derivative with the quotient rule. I did the product rule, etc. So just more examples of doing the derivatives with implicit differentiation. And notice, notice that there's each one of these problems has only one dy dx. But the next video will have a double, and the next one after that I'll have a triple. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. The content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.